Welcome to Category Visionaries, the show dedicated to exploring exciting visions for the future from the founders who are on the front lines building it. In each episode, we'll speak with a visionary founder who's building a new category or reimagining an existing one. We'll learn about the problem they solve, how their technology works, and unpack their vision for the future. I'm your host, Brett Stapper, CEO of Frontlines Media. Now let's dive right into today's episode. Hey everyone, and welcome back to Category Visionaries. Today we're speaking with Gary Calnan, CEO and co-founder of CisLunar, a space tech company that's raised $5.7 million in funding. Gary, welcome to the show.
Hey, thanks for having me, Brett. This is really great. Appreciate the invite.
No problem. Super excited to chat with you. So let's talk here. Space companies. This can't be easy. When the world of cybersecurity software tools and e-commerce plugins, you chose to go the hard route. Talk to us about that.
Yeah, man. I mean, I have always had a passion or an interest anyway in space. I've been interested since I was a little kid. Even tried my hand at going to the Air Force Academy for a couple of years before I decided it wasn't for me as a path to become an astronaut. And I had my eye on the space industry for a long time. You're right. There are easier ways to make money in the startup world. But, the one thing that's really amazing about the space industry is the whole community, really, especially these days with all the new stuff that's happening. You're really out there on the frontier creating the future. And we imagine what we want to see become possible. We see the science fiction that we have all grown up with and want to make it reality. And this is one of the few industries where you can do that. So that's one of the things that drew me to it. And, it's an area that's got a lot of blue ocean to go tackle for opportunities. So
what percentage chance do you think there is that someday you'll go to space?
Ooh, percentage chance. I mean, I definitely want to. I actually think that the chances are quite high. I mean, I think within my lifetime, there is better than 50% chance that I'll go to space. And I would probably put it more better than 75% chance.
That's amazing. How have you seen the space industry evolve since you founded the company in 2017?
Yeah, actually, that's an interesting question because in 2017, we were definitely a bit early. And I went to the International Space University. That was my way of getting into the industry and feeling like I had a seat at the table. Had a little bit of education. I don't have an engineering background. I come as an entrepreneur and a business person. And when we came to the industry, we started out in Luxembourg because Luxembourg was pursuing this space resources initiative. So they were interested in what we were working on, which is processing metals in space. And they saw that as part of that ecosystem. But at that time, when we looked at the United States, where, I'm an American citizen, born and raised here, there was less focus on debris, dealing with debris, finding some ways to handle the space debris problem. And part of our core approach is to process space debris as one of the feedstocks to create metal materials for in-space manufacturing. So I really seen the US government and NASA and the policy world really move towards wanting to tackle space debris as a serious problem and seeing the opportunities in space manufacturing and having that whole entrepreneurial aspect of that flowing into this as well that really energized the whole ecosystem for space.
How big of a problem is space debris? Can you just paint a picture for us?
Sure. Yeah. I mean, it's a problem that is growing exponentially. There's something like over 10,000 objects in space right now. And these are intact objects. So these are old satellites, upper stages, and a little more than half of them are like viable satellites that are operational right now. The rest of them are left over from old launches from the beginning of the space era. And this process is growing exponentially. The number of satellites that's expected to be in orbit, active in orbit in the next decade or so is expected to go up by an order of magnitude. So we're talking about increase that could potentially go up to 100,000 satellites in orbit at various altitudes. And as that gets more and more congested, the problem of having any pieces up there that are not controlled, which is what makes them debris, becomes more and more of a problem. If there's a collision, that debris can create millions of pieces of smaller debris that is moving at extremely high velocities at cross direction to other orbits. And when they have an impact, it can destroy other satellites. So we really need to make sure that there's a way to deal with this and to deal with it in an economically sustainable fashion to create true space sustainability.
And what's your solution? How are you tackling that? How are you solving the space debris problem?
Yeah, so the way we got into this business, we originally were trying to figure out something that would be impactful to the industrialization of space, the creation of a sustainable presence for humanity beyond Earth. And we identified the use of resources beyond Earth as a key piece of that. And as we were analyzing the ecosystem when I was at the International Space University, we saw, there were companies doing extraction like asteroid mining and lunar mining and companies that were working on manufacturing, but not really anyone who was working on processing materials. And then at the same time, I learned about space debris. And this is where the space debris piece ties into that. We were thinking, oh, we can be the steel mills of this industrial economy. That is the core vision of the company. But space debris is a problem today. It's also potentially a resource. So if there's millions of kilograms of materials out there that's already refined metals, doesn't have to be extracted from virgin ore that's in an asteroid or on the moon, why not figure out how to process that material and use it as a resource, tap into it as a resource. And then by doing that, we create the technology to process other kinds of materials as this economy grows. And at the same time, we take that debris that is currently a very expensive, somewhat intractable cleanup problem and turn it into a potential mining opportunity so that the economics of it actually drive the cleanup itself. That's kind of the long-term vision of this as the economy grows and the demand for materials on orbit also grows.
And if we look at who's buying this, is it private companies that are out there to protect their satellites from being damaged by debris? Or is this more of a government sale and a government problem that you need to get the government bought into it?
Yeah, I mean, it's a multi-stage vision for how this unfolds, right? So right now, the primary customers for any sort of in-space manufacturing, especially cleaning up debris, which is not in-space manufacturing, but it's in the same ecosystem, is going to be government. There are companies working on debris removal, and they've made a lot of progress thinking through different business models where you involve insurance companies or commercial companies might be incentivized to have certain objects removed from an orbit that crosses one of their very valuable satellites, might cause risk to that satellite in the future. But in the beginning, I do think that there's a heavy need for government involvement to finance the creation of the technologies and some of this initial cleanup capability. Once the larger industrial economy in space emerges, and it is starting to emerge, but it's still very early days. Once it emerges and there's a need for materials to build things like large structures for space-based solar power or large space stations or big antennas, there's a range of applications. Once that demand is there for those materials, then that will create a commercial incentive to go out and harvest those materials, those old pieces of debris, bring them to a recycling platform, process them, turn them into something useful. We can also actually make propellant or fuel from a perspective of most people for certain kinds of rocket engines that use electricity and solid fuels, solid metal propellant out of that debris to help fuel the collection of the debris itself. So that's another potential product that can be sold that could be both commercial and, with government interest, especially with entities like the Space Force for maneuver and being able to have that freedom of movement in space.
This show is brought to you by Frontlines Media, a podcast production studio that helps B2B founders launch, manage, and grow their own podcast. Now, if you're a founder, you may be thinking, I don't have time to host a podcast. I've got a company to build. Well, that's exactly what we built our service to do. You show up and host, and we handle literally everything else. To set up a call to discuss launching your own podcast, visit frontlines.io/podcast. Now, back to today's episode. Were you just sharing that on when the Space Force was announced? I think that was in 2018, 2019?
I mean, there's been a lot of jokes made about it. There's a whole series about it. It's a comedy. But yeah, I think it is a really important distinction to draw inside the armed forces to create the Space Force. I mean, there's been a lot of focus on space across the military, but organizing it under one branch, under the Space Force, which is a sub-branch of the Air Force, actually, but really allows that focus to be on the space activities. And I think it was a good move.
In the early days, was that a little bit nerve-wracking to think that for the short term, you really have one potential customer, which would be the U.S. government, or maybe a little bit outside of that, friendly governments, the United States. But I would guess that the U.S. government was that big number one customer. Was that scary going into it with that idea?
I mean, we were trying to find ways to make it commercial from the very beginning and trying to find ways to create the business case that would make sense for companies to start to create these materials. And we went through many, many iterations for how this might be structured so that that could be possible. It turns out that NASA, in 2021, we won our first NASA SBIR related to recycling and processing space debris, objects outside the space station. But we had created a number of different potential commercial avenues for this. It is a little nerve-wracking to have one customer, but I will say that NASA has been an incredible partner, and so has the Space Force. And now we've also got DARPA and the ISS National Lab and the state of Colorado, who have all provided government funding to help us drive the technology forward. But along the way, we were encouraged from the very beginning to find terrestrial applications for our technology, Earth-based applications, because everybody kind of saw that the commercial time horizon was quite distant, like probably a decade out for metals and materials to be really a big commercial market in space, even if they all believed that it was going to be big. So we kind of struggled in the early years trying to find out what that would be. And then recently, in the last couple of years, we've actually created another technology, which is our power conversion systems that has emerged as our primary commercial revenue driver in the next, I would say, probably the next 5 years at least. And that's going to really carry the company forward. While the government helps to support the tech development on the metal processing side, the power converter business will drive commercial sales and help us to grow the company on a commercial basis over the next few years and then into the future as well. And we can dive into the details on that if you want to.
Yeah, what led to the development of that product? What was like the aha where you said, okay, we have a viable product here?
Yeah, so this is kind of, I don't think this is very uncommon actually with entrepreneurial stories, but probably especially with hardware. We had in our first NASA contract, phase one SBIR, relatively small dollars to develop this metal recycling foundry that we could process metals with. And when we built that, we were operating it with induction, electromagnetic induction. So it's like how your induction stove can create heat in the pot. And anyway, we can talk about the details there if you want to. And the induction is how the furnace creates heat in the metal. And any metal will work with this process. It also allows us to control the metal. So induction was a key piece of the idea. And we had to build our own power converter for that because everything we went to go buy off the shelf for this project was like big and expensive and not really designed or would be designed to go to space. So we built our own. And then, we brought on this amazing engineer who just by some luck ended up moving to Fort Collins around the same time that our phase one project was ending. And we were doing our demo of this technology. And he's an electronics engineer, brilliant electronics engineer with experience in a variety of different things, including Tesla coils, which happens to have similar electronics to our furnace, ironically. And he just figured out how to make that box that was driving the power, which was originally like the size of a toaster oven, if you can imagine that. He shrunk it down to something about the size of a deck of cards. And it still pumps through the same amount of power, 2 kilowatts of power. It can do all the stuff that we needed to do. And so we were still pushing with the metal processing. And we went to one of our expert collaborators at CSU. We're talking about the technology we're developing. And he's like, you know what, guys, this thing looks a lot like a power processing unit for propulsion and for other things too that people need in space. And you should look at that. So we took a look at it and realized that, yeah, everything in space, all the satellites you see, except for when you light the rocket with chemical propulsion to send it somewhere, everything else is electrical. Electricity is coming from solar panels or maybe a nuclear reactor or some battery or something. And then it's being transformed from the state that it comes from that source, the way it comes out of that source, transformed into a different type of voltage and amperage and frequency to be used in another use case, whether that's propulsion or, we've done this with high voltage for welding applications. We've looked at this to run the satellite, the core of the satellite called the bus. So all these different things that are running on a satellite, all electrical. And once we realized that was true, we're like, oh, wow. So we could apply this core technology that we need for our furnace anyway to thrusters and space manufacturing technologies like welding, to driving the brains behind the satellite, to radio transmitter, to all these different things. And then, we would have potential applications across the entire industry. And that was just like evolved out of our need to build this thing for our own purposes anyway. And a couple of tips from friends in the industry. And as we explored this with partners, we've found there is a ready market for this for many different applications. And we've even been able to get a patent on the core design as well. So we're off to the races on this one. And we actually just flew it recently on a flight, which we just announced today on a press release, suborbital flight with our partners at Think Orbital, who used our technology to run their in-space welding technology.
Super, super interesting. How do you think about your positioning in the market?
Yeah, so there's really 2 key markets that we're tackling. One is the metal processing, sort of in-space resources market, and our positioning there. We've really become the leader in terms of especially recycling and processing metals that are already existing in space. So old spacecraft or satellites that have reached the end of life, or even metals that might be derived from mining operations on the moon or on asteroids. Especially with our latest project with DARPA, on their DARPA Luna 10 project, we were sort of identified as the leader in this niche market of processing metals in space. That's how we're positioning ourselves there. We're trying to stay at the forefront of different applications for that. And then with the power converter market, it's a little different because that market is not new. There certainly are companies that have been providing these capabilities throughout the years. Where we're really positioning ourselves right now is kind of have to do with how the market has evolved. So as new space became a thing, as these entrepreneurial space companies started launching small satellites that didn't require a lot of power and weren't as big as a school bus, the satellites shrunk down real small. And there became a lot of manufacturers that would supply power converters, power transformers for small satellites that would be 100, 200, 300 watts kind of systems. And that market is pretty, I wouldn't say saturated, but there's plenty of suppliers there. But wasn't being approached as much was the higher power market. And since we needed high powers for our furnace, we already were developing high power systems. And it turns out that there's only a few manufacturers that develop high power, 1 kilowatt and above kind of systems for the industry. So we found an opportunity there to penetrate that market and provide a system that has some advantages from a size and weight and efficiency basis, as well as a scalability and adaptability basis by using our core technology and having it be kind of modular and almost like Lego bricks, where you can build them up to be as big as you need them to be or scale them down and apply them to different use cases. And that's where we're positioning ourselves now, is that one of the leading, we're early, but we want to become one of the leading suppliers in this higher power segment where we're going to a kilowatt and above, which is where we see a lot of the satellite market trending towards, because these larger, more capable satellites.
Yeah, something else that I wanted to ask earlier and I forgot was about government contracts. What have you learned from securing government contracts? And the reason I ask, I think a lot of founders, I don't know if you've been seeing those headlines, but defense tech is cool now. There's a lot of people in defense tech, everyone's talking about it. So there's a lot of buzz there. And I think there's a lot of interest now for Silicon Valley and just tech companies in general to work with the government. What's that process like and what have you learned?
Yeah, I mean, it's a little bit daunting at first because it's unfamiliar. There's lots of jargon, especially when you get into the military, there's even more jargon. So it is a little intimidating at first blush. And I think that's why historically a lot of companies have steered clear of that. What I have observed is that most intelligent people running businesses are generally intelligent people, can figure out how to navigate if you want to. And it is a process. It does require dealing with some bureaucracy. And you need to spend a little bit more money for certain systems like email and so on, so you can meet the security requirements. But it's doable. And if you have a good product, the SBIR process, the Small Business Innovation Research Contracts process, which is available throughout the US government, and every department has to have some money allocated to this. So any technology that you're developing, whatever industry it is, there's probably an SBIR that you can tap into that you could get some money for this. And it's great because it's early stage, non-dilutive funding. They're framed as contracts, and you get tied into the government system. And depending on I don't know about other agencies, but we've dealt with NASA, Space Force, DARPA, ISS National Lab so far. What I've also noticed is my expectation was that you expect bureaucracies are slow and kind of hard to work with, and maybe a bit opaque, not willing to work with you as an entrepreneur. But I've actually found it to be kind of that to not be true, especially with the Space Force. We've observed that the Space Force is a new agency. They're trying to be adaptable to the industry as it is and take advantage of the benefits of entrepreneurship. And they've moved pretty fast, and they've been very helpful and collaborative with us. So it seems daunting, but it's not as bad as it seems, I guess I would say. Sometimes it takes a lot of tries at bat to win some of those contracts. And you don't really know what you're doing the first time around. Maybe you won't win it, but you'll learn and you'll get feedback. And putting it out there to get that feedback is super helpful.
This show is brought to you by the Global Talent Co., a marketing leader's best friend in these times of budget cuts and efficient growth. We help marketing leaders find, hire, vet, and manage amazing marketing talent for 50 to 70% less than their US and European counterparts. To book a free consultation, visit globaltalent.co.
Just to set expectations there, what was that like for you? Did you try to win 50 contracts, 1 or 2, or did you try to win 3 and you won 1 or 2? What was it like for you?
Yeah, I mean, so the first interaction with government was not the US government, it was Luxembourg government. And we went through about 2.5 years and multiple rounds of proposals with them that were very big and time consuming. The Luxembourg Space Agency is great, but it just wasn't the right fit at the right time for us with them, apparently. So anyway, we moved to the United States, and ironically, our first try, we did try a NIAC proposal, which is a type of NASA really advanced concepts proposal. That didn't go through, but we won our next one. I don't think this is super common, but we won our first SBIR proposal to NASA. We had a couple of things that went in our favor. A couple of the companies that would have been prime competitors for this were acquired by larger companies and were no longer eligible as a small business to participate. So we had kind of a more open field to participate in this particular request that they had. And we brought on our CTO, who was our last co-founder of the company, Joe Pawelski, and he really brought some technical rigor and maker mindset to that process. And we were able to win that one. So I think we got a little bit lucky with some of the aspects on that we won. I guess it was our second try on that, or maybe it was our third try, because we also tried to do an ISS National Lab. On the other ones, we've done a couple tries on most of the other agencies before we've gotten in the door. And once you start to get in the door, and people see that you can produce things and you can build stuff and successfully achieve the project, you'll find that, well, what we found is that you get more opportunities to propose to more things, and you start to build a reputation amongst those who are evaluating these things.
What about the appetite from investors, I should say? I'm a big follower, a big fan of Josh Wolf from Lux Capital. I don't know if you ever saw that article, but it was like Inside Josh's War or something like that, just talking about their approach to betting big on defense. What have those conversations been like for you with VCs if we compare them to 2017, 2018, the early days, to the conversations that you're having now?
Yeah, I mean, trying to get to investors with this idea has definitely been a challenge. The real challenge for us is that the market, we're creating a new, like this podcast is about new categories, right? We're creating a new category here with this metal processing that hasn't had any real commercial action yet. And it requires a visionary investor who gets it and gets the big potential and who's willing to invest in a longer time horizon. So one of the big challenges we've had with typical VC investor is that our time horizon to get to commercial viability for metal processing is not your typical 5 to 7 years. And that just doesn't fit with the turnaround time that most VCs typically say they need. So there are other kinds of investors who have a longer time horizon, but it just takes longer to find them and meet them. Our first VC, actual institutional investor, didn't come on board until this first quarter of this year. So we're still early on our process of getting actual institutional capital in. We've had friends and family and angel investors come in on board for our the 1.2 million that we've gotten from investors so far. But it's a challenge, no doubt about it. And it takes some creative thinking and trying to figure out how to explain a complex market and solution to investors who may see this as not the immediate market opportunity. Now, power converters is a little different. That's opened up some new doors, but
I can imagine. Are you seeing that there's more appetite, or I should say, just are the conversations going better now than they were a few years ago?
Absolutely. And now we're even getting more inbound interest as well, which is always great. But we do see, well, of course, as you're well aware, and probably most listeners are aware, there was a bit of a VC downturn until recently for at least a year or so, where a lot of the market was doom and gloom, market had pulled back, VC winter, all these kind of comments. And we definitely saw that it was even harder to get people to start looking at it during that time frame for about a year and a half or so between, I guess, towards the beginning of this year. Prior to that, it was pretty difficult timing for trying to raise money. Kind of came after like the SPAC boom and all that stuff where it was very frothy. So it was just the mirror image of that. But now it seems to be loosening up. I think we're come out of that downturn. People are starting to want to use that capital that's on the table there. And yeah, it's definitely getting better. Plus, we've gotten a lot more traction. So for us as a company, having all that government support in the beginning has definitely made a difference for showing traction.
Yeah, just taking a pulse from all of these conversations, I've had about 600 of them now. They were very depressing there for a year or so. I think in like late 2021, early 2022, there were tough conversations with a lot of the venture-backed founders out there. But now it seems to be trending in a more positive direction. So that's a good sign.
Yeah, I think so. And some of it is just about figuring out how to survive those moments in time. Like, structure your company with optionality. So you have more than one way to move forward where you're not dependent upon like continuing to raise so you can keep burning capital. I mean, we even took contract engineering deals with some customers who were aligned with us strategically, where we were helping them with things that were complementary, but not what we wanted to be working on it for ourselves. And that allowed us to bring cash in the door and even hire people new to the company, even though we couldn't raise money. So there are other ways to get there. You just got to be scrappy.
Yeah, I think that's the advice that a lot of founders say, a lot of investors say, is it's all about survival. I think the famous startup example of that is Airbnb and the cereal story.
Oh yeah, I love that story.
It's almost like too perfect. It is the most perfect startup story that exists, I think.
The only thing it's a great story. And the thing about the cereal thing is it's so out of left field. And it's not like it's remained as part of their business, right? Ideally, you want to find some kind of spin-off opportunity that's not just like a gimmick to get some cash. But hey, if it works and it gets you through a crux, do whatever you got to do. So
survival is survival, I guess.
That's right. Exactly. Exactly.
Now, I think, anyone when they're a kid, they dream of being an astronaut. For most of them, that doesn't happen. But the next best thing, I think, is to be a space tech entrepreneur, a space tech founder like yourself. So given that you've spent a lot of time in this industry, what's the number one piece of advice that you'd give to an up and coming space tech founder or just a founder that wants to build a space tech company?
Yeah. I mean, you have to have the passion, first of all. If you don't have it, like I said in the beginning, there are easier ways to make money from an entrepreneurial perspective. So you really have to be bought into this to go through the long ups and downs. And every industry has that with startups, really. But I think it's especially true with something like the space technology industry. It definitely helps and it comes through. The other thing I would say is like one of the things that really helped us was just getting out there and telling our story, especially if you're doing something that's more niche or out on the frontier edge of space technology. I think going to conferences, telling people what you're building, we made a decision early on that we were small and we didn't have our own pile of wealth to use to build a business. So we had to go out and tell the story and try to find partners that we could work with, help, add value to, and leverage to get these government contracts and so on. And that proved to be extremely valuable decision for us to make, to go out and tell the story, be open about it. We decided not to go stealth from the very beginning. And I encourage any entrepreneur, unless you're independently wealthy and you want to just fund it, even still, making contact with the market is always better to refine your idea. And, and being willing to be flexible and open to changing paths, and don't get married to one kind of technology. But I mean, this is not unique to space, actually. I think this is any kind of hardware tech startup.
Did you watch the Palmer Luckey kind of mini documentary on Bloomberg?
I think I caught the one you're talking about. Yeah, it's a fascinating story that he's got.
I think I'm there getting that hardware is hard.
Yes, hardware is hard. And it can be very capital intensive. But I mean, I think things are already said. And it's also making sure that whatever you, at least for us anyway, we always tried to approach what we were building to maintain as much flexibility as how it could be applied as possible. So we didn't say like, what's our killer app? It's going to be large antennas in space or whatever. Like, we don't know because it's such a new market. And I think keeping an open mind as to how your technology can be applied can uncover some very unexpected opportunities, which is exactly how we got into this power processing business.
Final question for you, since we're almost up on time. Let's zoom out 3 to 5 years into the future. What's the big picture vision here?
Yeah, so 3 to 5 years into the future, our vision really is to help open up the solar system for humanity. We want to see, and this might be more than 3 to 5 years, honestly, but I mean, from our perspective, having metal processing and having this capability is a fundamental cornerstone to any industrial economy. And in order to expand on a sustainable way out beyond Earth, we need to have that industrial foundation in the Earth-Moon system, or CisLunar space, which kind of encompasses the Earth orbits and the moon lunar surface. And so our vision is to make that a reality and to supply the industry with materials, end-of-life solutions, and to be able to take space debris cleanup and turn it on into an economic opportunity instead of something that's just a cleanup exercise, and to really enable the industry to grow and develop into a solar system-wide economy eventually. I mean, that we want to be at the foundational part of that and develop these key capabilities. That metal processing or materials processing and power conversion are two of those. Power processing capabilities are two of those key pieces to that puzzle. And we're carving out a strong niche in that area. And we expect to grow. Right now, we're 15 people. I think we have projections in 3 to 5 years to be in the range of like 50 to 70 people. And we see a lot of opportunity to supply the industry with the power and the metal processing capabilities.
Amazing. I love vision. All right, we are up on time here. Before we wrap, where can people follow along? Where should they go if they want to keep up with your journey?
The space industry is heavily on LinkedIn. We find ourselves announcing things there mostly. Also, we have a website, CisLunarIndustries.com, where you can keep track of the latest and greatest, but probably LinkedIn is the best place to follow us. You can find any of the co-founders there. We're not hiding our contact information. So, if people want to reach out and connect about things, we're always open to doing that.
Amazing. Gary, thanks so much for taking the time.
Yeah, thanks for having me on. It was a lot of fun.
This episode of Category Visionaries is brought to you by Frontlines Media, Silicon Valley's leading podcast production studio. If you're a B2B founder looking for help launching and growing your own podcast, visit frontlines.io/podcast. And for the latest episode, search for Category Visionaries on your podcast platform of choice. Thanks for listening, and we'll catch you on the next episode.